Sometimes solving trigonometric equations is very difficult, but with the help of substitution, you will be able to solve it easier and faster. So in this tutorial, I would like to show you how you can replace trigonometric expressions with algebraic expressions. Let's get started. Remember, if you have tangent of 2 theta, this is equal to 2 multiplied by tangent theta divided by 1 minus tangent squared theta, right? This is true for tangent 2 theta. Then what if you divide the entries by 2? You have tangent of theta, because 2 theta divided by 2 is theta, to be equal to 2 multiplied by tangent of theta divided by 2 divided by 1 minus tangent squared theta divided by 2. So we have divided the entries by 2. So our substitution will be in the form of tangent theta divided by 2 be equal to t, which implies that wherever we have tangent of theta divided by 2, that will be replaced with t, which means that tangent of theta to the left equal to 2 times t divided by 1 minus t squared, right? So this is our first substitution, which means that whenever you are solving a trigonometric equation where it contains tangent of theta, you can confidently replace it with 2t divided by 1 minus t squared. Then solve the equation in terms of t, but remember in the end to back substitute the value of t to be tangent of theta divided by 2. Then you take tan inverse of both sides. Yeah. Then its reciprocal cotangent will be equal to the reciprocal of this, which is 1 minus t squared divided by 2t. So what about sine, its reciprocal, cosine, and also its reciprocal? I can do that using a right angle triangle. Angle theta. Remember that tangent of theta is 2t divided by 1 minus t squared, which is the ratio of what? Opposite and the adjacent sides. This is the opposite, 2t, and this is the adjacent, which is 1 minus t squared. So what will be the hypotenuse? The hypotenuse is the square root of this squared plus that squared. That is 2t squared, that is 4t squared, plus, if you square this is a binomial expansion. You take the first term, you square that, 1 squared is 1. Then 2 times 1 is 2, times negative t squared will give us negative 2t squared. Then lastly, you square negative t squared, that will give us positive t to the power of 4. So this is what you need to simplify to get the hypotenuse. So let me do it here. This will be the square root of t to the power of 4. 4t squared minus 2t squared is just 2t squared. Then we have plus 1. This can be written as the square root of t squared all squared plus 2 times t squared plus 1. Remember, we have 1 here, which is a quadratic expression in terms of t squared, and it is a perfect squared because half of 2 is 1 and 1 squared is 1. So this is now finally equal to t squared plus 1 whole squared, and this power of 2 will eliminate the square root, leaving t squared plus 1. So therefore our hypotenuse is 1 plus t squared. The reason why I start writing 1 is because of this. We have 1 before t squared. So let's continue. What will be sine of theta? Opposite divided by hypotenuse. 2t divided by that. 2t divided by 1 plus t squared. Then what about its reciprocal? cosec theta will be 1 plus t squared divided by 2t. Then we have cosine, which is adjacent divided by the hypotenuse. The adjacent side is 1 minus t squared. The hypotenuse is 1 plus t squared. Then lastly, its reciprocal, which is secant, will be 1 plus t squared divided by 1 minus t squared. So all of these 6 ratios, when you encounter them in an equation, you can confidently replace them with this. If it is secant you see, replace it with this. Cosine theta, replace it with that. In that order. Solve the equation in terms of t, then you back substitute the value of t in the end to be equal to tangent of theta divided by 2. Then you take tan inverse of both sides to have your theta over 2 to be equal to tan inverse of that value of 10 for t. Then you add your multiples of pi. Right in the end you multiply by 2. Where should I do that? You multiply by 2, this becomes theta. This becomes 2, 2. And you're good to go. This is how you can solve that equation with algebraic substitution. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.